Alright, homies, welcome. Today we're going to talk about our two first types of factoring that we're studying in class. The first being removing a greatest common factor. So if we look at these two terms, 45a7b3c minus 63a to the fifth b to the fourth. These are not like terms, so what we want to do to simplify is to remove the greatest common factor. So what we're going to do is we're going to leave our greatest common factor outside, and then within the brackets we are going to leave what's left after we divide by the GCF. So in these terms, we look at what's the largest thing we can remove from both 45 and 63 first, our coefficients. You could do the factor tree method, you could list all the factors, but to save some time today, we're just going to look at these and we'll say that the biggest number that divides evenly into both of them is 9. After that, we're going to look at the a to the 7th and a to the 5th. So because a to the 7th means a times a times a times a times a 7 times, and a to the 5th means a times itself 5 times, the most a's we can remove from both of those is actually the smallest exponent, which is going to be a to the 5th. Same thing with the b's. Here we have 3 b's, here we have 4 b's, so the most b's we can take out of both is the smallest exponent, or b to the 3rd. Next up, we're going to divide each of these terms individually by the greatest common factor, which is 9a to the 5th b to the 3rd. So, when we divide 45 by 9, we of course get 5. When we take away 5 a's from 7 a's, we're left with 2 a's. If we have 3 b's, we take away 3 b's, no b's left. And then we're just left with 1 c in this first term. The minus stays. Same thing with the second term. 63 divided by 9 is 7. A to the 5th, remove 5 a's, we're left with none. And b to the 4th divided by b to the 3rd gives us 1 extra b. So here's our final answer, 9a to the 5th b to the 3rd, brackets 5a squared c minus 7b. That is completely simplified by using the GCF, which was also my nickname back in college because I was the greatest. Alright, next up we're going to look at a different sort of problem. Here we have 4 terms. There's no common factor to all 4 of these terms, so what we're going to do is we're going to factor by grouping them into 2 pairs. So we are just going to find each of these pairs individually. So, first of all, finding the greatest common factor of 15a squared plus 3a. What we can remove from both of those is going to be a 3. Then we can take an a out. And then again, same as the last problem, when we divide, we're left with 5a. 3a divided by 3a is 1, so 5a plus 1. Next, we're going to do the exact same thing with the second pair circled in blue. We have negative 20ab minus 4b. The greatest common factor of negative 20 and negative 4 is not only 4, but we can also remove a negative 4 from each. We'll see why in a second. We can also take a b out of both because there's a b common to both terms. Then when we divide each of these by negative 4b, we're left with 5a plus 1. So you're now looking at this, and I'll do it in the colors so that becomes obvious. What we have here is basically one large term and a second large term. And if you notice, especially with the colors, we have a greatest common factor of each of these terms. That factor is 5a plus 1. And when we remove that, here's what we're left with. We're left with a 3a in the first term when we remove the 5a plus 1, and a negative 4b. This, my friends, is our final answer. Brackets 5a plus 1 times brackets 3a minus 4b. Glad to drop a little knowledge on you. Let me know in class if there are any questions. This has been Factoring by GCF, and factoring by grouping with your boy D Shizzle. Peace out.